GE Aviation, we make the engines for the airplanes. And so one of the things that I want to talk about before we get started with our experiments today is the four forces of flight and how engines contribute to that. And then what we'll do is we'll go into a little bit more detail on the thing called Bernoulli's principle. And that is the principle behind lift. And we're going to do a couple of experiments to see if we can recreate Bernoulli's principle. We're also going to talk a little bit about variables or factors that happen in experiments that make them work better or not so great. So I'm going to attempt to show you Bernoulli's principle in 3 different ways, and we'll see which way we're. So here's a picture that I drew that shows the 4 forces of flight. So the first one is gravity. Most people are pretty familiar with gravity. Whenever you drop something, when you try to jump, you come back to the ground. And the thing about gravity is the heavier something is, the bigger the force of gravity. So that kind of explains why when you fly on an airplane, they're pretty picky about how much luggage you bring and how much it weighs. Because the heavier your luggage is, the heavier the airplane is, and the more gravity that lift has to overcome. And the more lift that you need, that takes more fuel, and that costs more to fly the airplane, and it pollutes the air a little bit more than it needs to. So the opposing force for gravity is, of course, as I mentioned, lift. And lift is what happens when air rushes over the wings of the airplane. So as the airplane, moves quickly, through the air, the air rushes over the wings, and Bernoulli's principle tells us that so the way that the wings are designed is we have the speed varies of the wind, how much it's passing over the top versus the bottom of the wing. And what happens is Bernoulli's principle tells us that because of the way the wing is designed, we have less air pressure on top of the wing than we have under the wing. We have more pressure under the wing, less on top of the wing. And so if you think about two forces where the pressure is less on the top, what's going to happen? It's going to start lifting, right? So that's what lift is, and that is from Bernoulli's principle, which we're going to talk about in a couple of minutes. Now, what makes the plane go across the sky very quickly, which in turn causes the air to flow over the wings very quickly? It's from thrust. And thrust, of course, comes from the engines. And in my simple diagram here, the 2 black circles represent the engines. And that's, of course, what I work on. And so the thrust pushes the plane this way. Now, the opposing force to thrust is drag. And you might also think about it as wind resistance. And I think most of us have experienced wind resistance in one way or another in our lifetime. Think about if you are standing facing the wind, or if you're riding your bicycle into the wind, you have certainly felt wind resistance. And when you're riding your bike, if you kind of lean over and make yourself smaller, you're having less surface area for that wind resistance or drag, and so the force is less. Another example would be if when you're in a car, if you stick your fingers out, or maybe part of your hand out of the window when you're going, you can feel that wind up against your hand. And if you do that when you're in the car, you're going to get a lot less wind resistance against your hand than if you do like that. And that's a lot of what shapes an airplane, is trying to reduce that drag or that wind resistance. And the same thing with a car. That's why the windshield of your car is sloped. and it's because of that wind resistance. So having gone through the 4 forces of flight, again, Bernoulli's principle tells us that when the wind rushes past, the air pressure drops in that area. So again, I've got our first experiment, which is probably one of the more difficult ones. So again, there's a lot of factors here that I'll admit to you. Sometimes I get it right and it works great, and sometimes it doesn't work and I can't get the experiment to work very well. So we'll see what happens this time. Because again, do you remember when I talked about what are the factors or variables that are on different experiments, that sometimes you can get it to work and sometimes you can't. And that's one of the most difficult things about being an engineer or a scientist or a programmer, is trying to figure out when things go wrong, why. You have to figure out what those factors or those variables are that made the experiment or the design not work. So, so what we're going to do here is we're going to try to show Bernoulli's principle. I've got a cup of water here. It's pretty much full. I've got just a regular drinking straw, and I've cut it so that it's close to the water line here. And then I have another straw, and it's bent. You could probably try it without a bent straw, but this is the instructions that I found on the internet. It suggested a bent straw. So one of the things that you want to try to do here is you want to blow air across the straw that's in the water. And you need to get the angle just right so that the air rushing across the top of that straw is real fast, and it makes the air pressure right around the entrance of that straw lower. And what that should do is that should suck up some of the water up that straw, because if there's less air pressure in the straw, then there's pressure holding that water down in other parts of the cup. It should start to rise up that straw. So one of the variables that, to be honest with you, I have difficulty in getting right on this one is what is the exact angle and how hard should I really be blowing? Some of the other experiments that we're going to do in a little bit here, one of the mistakes I kept making was I was blowing too hard. It took a lot less air than what I thought it did. So if this works, when I blow, you should see some water mist out of this straw. And I'll try a couple of times, because I'll be honest, it's a difficult one, and I'll be interested in finding out if the girls at home can get it to work better than I can, and if after you try it at home, if you can come back and post what were some of the things that made it work better. Okay, now it was kind of subtle, and I could see water that spewed all over my screen of my tablet here, so I know it worked. So what happened was water sucked up the straw, and it misted out, and it went all over the screen of my tablet here. So again, it was the lower air pressure right there at the entrance of the straw, and that water just came right up the straw, and then of course it got caught in the airflow of me blowing through that straw and went straight through. Now I have my own theories. Yes, did everyone see the water mist? I'd be interested if you guys were able to see it. Now one of the things, let's take a guess, and did you think that it was better if I blew straight down into the straw, straight down, if I blew perpendicular, or if I blew straight down? I'd like to hear some of the comments from folks if you think which was the best way for it to work and to create that air pressure change. And in a couple of minutes, we'll come back and see what everybody thinks. So Rowan, and I hope I said your name right. I apologize if I didn't. She did see the mist come out of the straw and towards the screen. So I'm glad that you were able to see it, because it can be pretty subtle. So the next thing that I'm going to do to show you Bernoulli's principle, it takes, I've got a couple of versions of it. So the first one takes 2 ping pong balls, and it takes some string, and I have different types of string. I tried different ones. I'm not entirely sure it matters. I use this crochet yarn, which is real thin string. I've seen on the web where people have used twine. I also tried yarn. So the important part is that you want to hang the ping pong balls from your string, and you want to put the string about 2 inches apart, because since the ping pong balls are about an inch, inch and a half in diameter, that'll just, once you hang them, once they're hanging straight, they'll only be about an inch apart, give or take. Harry's back, so I apologize if he's barking. He wants more treats. So the experiment, the first time I tried it, I used this stick. I think any kind of stick would work. Now what I had difficulty with on this one was to hold the stick still. I had a lot of trouble with that, because when you do the experiment, the balls need to be hanging from identically the same length string, and they need to be still. So when I was holding the stick, no matter how hard I tried, I couldn't keep it still enough. So what I ended up doing, and I'm going to move my camera, so bear with me, was I actually ended up taping the strings to the ceiling. Now ask your parents before you do that. Since my mom lives in another house, I didn't have to ask her permission, but you probably want to make sure your mom or your dad or your guardian is okay with you taping these things to the ceiling. So hang on with me. I'm going to put my camera so you can see where I've hung these balls. And what I'm going to do is I'm going to take several things. We're going to try several things here. We're going to try several ways to blow air between these balls. There's 3 ways we're going to try it. One is with a straw, one is with a toilet paper roll, and one is just simply to just blow without anything directing it. So, and now it's pretty subtle. And when I think I have seen what you're supposed to see, I'll say, "Did you see it?" And then I want you to comment what you think you saw. It's a little bit subtle, so watch for it. Now, if you think about it, when I blow air between there, the air rushes through, and there's less air pressure in between these balls than there is around them. I want you to try to think about what you think is going to happen. What your mind wants to tell you is when you blow it, those balls are just going to go forward or apart or just start spinning. But that's not necessarily what happens. So let's try the straw first. Okay, it happened. So let me make the balls still again, and I'm going to try again. Ready? And I'm going to do the straw. It happened. Now, the first time I tried this, what I did was I blew as hard as I could through the straw, and I didn't get as good of results. In this, what I just did right now is I blew very, very gently, kind of strange. I would have thought that I would have did, you know, the first time I tried it, I went, you know, you can't really see the Bernoulli experiment there because I was not very careful in where I blew. The next thing that I tried was I tried to blow through a toilet paper roll. Let's give that a try. Now, it didn't happen that time. So there's something about directing the airflow from a smaller diameter, and I think that makes the airflow go through there faster, and it makes that air pressure change more. Now, hey Lauren. Lauren is off screen, and I also want to recognize Marnie, who's doing our chat window. Lauren, can you move the camera so that the girls can see the balloons here? Thank you. Thanks so much. So I wanted to try some different variables. So I got a couple of balloons in Girl Scout colors, naturally. And I wanted to see what would happen with balloons instead of the ping pong balls. Now, the other variable, besides a different shape and a different weight, I also put them a different width apart. So let's see what works the best with this, whether it's the straw, the toilet paper roll, or me just simply blowing on it. It tried. It tried to do what I'm looking for. It did do it that time. Let's try it one more time. Not quite that time, but it was trying. Let's try it with the toilet paper roll. Didn't work so good. Mostly what I did was I just blew the balloons towards you. So the last thing is, let's just try without any direction, you know, without any straw or tube at all. And she's absolutely right. So again, when I blew in between those two balloons, when I blew in between those two ping pong balls, I made the air rush in between them, which made the air pressure change and go lower in between the balloons. So of course all the air pressure was around the balloons and the ping pong ball, and it moved them together. And it's that same phenomena, just in a little bit different direction, when the air is rushing on top of the wing of the airplane, and below it, it causes that air pressure to change. Because of the shape of the wing, it causes that wing to rise. So Harry and his assistant Daisy congratulated Rowan on getting the answer. So let's see if Harry is willing to say goodbye. Come on over, Harry. Oh, he lost his wings. So Harry wants to say goodbye, and I hope that you enjoyed this video, and that I hope that you will tune in every Friday to see more experiments with our GE employees. Bye, girls.